Hello, this is Omar Ashraf, grade 10 Alabama, and today I'm going to be talking about green energy, specifically wind turbines. First off, we need to know what's wind and how it is created. Wind is a form of solar energy caused by a combination of three concurrent events: the sun unevenly heating the atmosphere, irregularities of the earth's surface, and the rotation of the earth. The idea of wind turbines is the opposite of a fan, where electricity produces wind. In wind turbines, it's actually the opposite, where wind creates kinetic energy by moving a blade around the rotor, which spins a generator, which creates electricity. The wind flow patterns and speeds vary greatly across the United States and other parts of the world, and are modified by bodies of water and differences in terrain. Humans use this wind flow or motion energy for many purposes: sailing, flying a kite, and even generating electricity, as the wind turbine does. The term wind energy and wind power both describe the process by which the wind is used to generate mechanical power or electricity. This mechanical power can be used for specific tasks, such as grinding grain or pumping water, such as in the old days where they used windmills and used the wind energy to grind the wheat grains and also pump water above hills. Wind turbine turns wind energy into electrical energy, as we've said before, but it uses aerodynamic force from the rotor blades, which works like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag. The force of lift is stronger than the drag, and this causes the rotor to spin. The rotor connects to the generator either directly or through a shaft and a series of gears that speeds up the rotation and allows for a physical smaller generator. This translation of aerodynamic force to rotation of a generator creates electricity. We've got two types of wind turbines: horizontal axis and vertical axis. Horizontal axis wind turbines are the one that everybody knows. We've seen in the movies, we've seen everywhere, and it's the most commonly used type, where we've got three blades that operate on the upwind, with the turbine looking at the direction of the wind, and the blades are located at the top of the tower of the wind turbine. And with this type of wind turbine, you have to point it directly at the direction of the wind, as this type allows the blades to take on the wind force at full speed without losing any. On the other hand, we've got vertical axis wind turbines, which they come in several varieties, including the egg beater style by Darius, named after its French inventor. These wind turbines can be placed anywhere, as they take wind energy from all around them, and you don't need to put them directly in front of the direction of the wind. But these type are less efficient, as they've got multiple wind coming from different directions, so it sometimes can be less efficient than the horizontal axis wind turbine, as the horizontal type takes it from just one direction and takes it at full speed, so it converts all the wind energy into electrical energy. But with the vertical axis, sometimes the wind can overlap each other and make the wind turbine slower and not generate as much energy as the other type. Fun fact: every 24 hours, wind generates enough kinetic energy to produce 35 times more electricity than humanity uses each day. Which means that if the whole world built enough wind turbines to collect and harness all the wind that's created, the world will be able to power itself 35 times more, and we won't need to use coal or oil or any other non-renewable sources of energy, and also providing a clean and better world. There are four primary factors for any wind turbine. First off, its size, as size can affect if it's too big. If it's too big, the blades will be too heavy for the wind to move, and if it's too small, it won't be able to contain the components for the wind turbine and won't be able to generate enough electricity. The orientation of the blade, which means the direction of the blade moving, as it sometimes can be affected, so you need to calculate where the wind is coming from to make sure that the orientation of the blade is in the same direction of the wind. Also, the blade's aerodynamic design, as it can affect, that's why the airplane wings are the most aerodynamic shapes, as wind can curve better and cut through, can move easier through curves and bumps. And for the amount of wind turning the rotor, as if it's too big of a force, the wind turbine can break, and if it's too little, it won't move the wind turbine at all and won't generate any electricity.